Hello, welcome back to the OBIS data formatting series. In this video, we will learn how to run some basic quality control checks on your data before publishing. We're going to use two R packages to run these checks. The first is OBIS tools, and the second is Hmisc. So the first thing, of course, we need to do is to load our data. So we have the event table, the occurrence table, and the extendedMeasurementOrFact. Now, if you get an error here, because of the presence of, for example, a degree sign in your coordinates or other characters in other fields, make sure you are exporting your CSVs in UTF-8 encoding. The next thing we want to do is check that all of our taxa names have matches in worms. You may have already done this step from the worms taxon match tool, but we can also do this in R with the OBIS tools package. So we will use the match taxa function. And we're going to specify unique here because our species names are repeated in the occurrence table, and we don't need worms to fetch identifiers for each of these repeats. And we will specify the scientific name column because this is the column where all of our scientific names are. And of course, we will store this information in an object called worms. Hit yes to proceed. Let's take a look at the worms table. So we can see there's a column with scientific name, a scientific name ID, and the type of match. Now we need to merge this information back with our occurrence table. So we will use the merge function and store that back to our occurrence table. So we'll merge the occurrence table with the worms table by the column scientific name, because this column exists in both tables. I'll run that. Now let's check our data. So we can see that the worms data has been appended to our occurrence table. So now we have this column scientificNameID.y. So we're just going to rename this column before we move on. Check that this worked. And great, our column has been renamed to just scientific name ID, which is exactly what we want. So the next step in our process is to check that all the required fields are present, and to do this we will use the check fields function. We'll check the event table first. Viewing the object, we can see the error and warning messages. So the first things we'll notice is that it says scientific name ID, occurrence status, and basis of record are missing. However, we know that these are present in the occurrence table, so that's okay. And it's also indicating that there are some empty values for event date, for a number of fields, as well as for decimal latitude and decimal longitude. These empty values may be due to the hierarchical structure of event tables, where they were not provided to avoid redundancy, or it could be that these rows are missing. This would be a good time to check these empty rows to see if they should be filled with the appropriate value. Next, we will check that all of our coordinates are in the geographic region we expect them to be in. So we'll use the function plot map. And again, we will specify our event table because this is where our coordinates are provided. So inspecting this map here, we can see that most of the coordinates are where we expect them to be on the eastern coast of Canada. However, it looks like there are some coordinates down in the Southern Ocean. This could be due to a typo, or perhaps the latitude-longitude coordinates were flipped. So this again would be an important place to go back and check for those records. An easy way to do this would be to use the plot map leaflet function to identify specific coordinates that are outside of the geographic scope. So although the base map doesn't seem to be loaded, we can still click on individual points to see which row in our data it corresponds to. So this point corresponds to the 12th row. Now if we view our event data and scroll down to the 12th row, look over at the coordinates, and it looks like the longitude values are actually provided in the latitude field. So we would simply have to swap these cells. The next step in the quality control process is to check the depth of our records and make sure that they are all within the expected range. So we will use the check depth function, and we will specify report equals true, and so the output will be a report. And we will view this object. So the first warning message is that the column minimum depth in meters is missing. In this case, I know that the maximum depth in meters was provided, but not the minimum. So if you have this data, we would have to make sure this field is populated. We also see several errors here, saying that the depth value is greater than the value found in the bathymetry raster. This could be an indication that you have a typo. For example, this row here has a depth value of 2,000 meters. That's very unlikely. However, some of these values may be flagged in error. This could be because the bathymetry layer that the package is checking against may be at a coarser resolution than your sampling. To help minimize records being flagged in this way, we can specify a depth margin to indicate how far a given depth can deviate from the bathymetry raster. We're going to specify a depth margin of 15 meters. We'll run this again. And now we can see only a few records are flagged. These two records on rows 21, 22 are still being flagged. And when we hover over, we can see that the depth of the raster is saying it's -2, and we've given the margin error of 15, and our depth value is 15 and 20. This is outside of the bathymetry raster, but in this case that's okay. However, this depth value of 2,000 is definitely a typo given the data set. When you look at the other errors, it's simply telling us there are some latitude-longitude coordinates that are outside of the bounds of the raster, and that there are no bathymetry values for certain coordinates. These are associated with blank records, and this is again due to the hierarchical structure of our dataset, where we have left certain records blank for decimal latitude and decimal longitude to avoid redundancy and repetition. The next check we want to do is to check that all of our event dates are formatted according to ISO 8601 and that there are no missing event dates. So we can see immediately that there are some errors saying that event date does not seem to be a valid date. These are again associated with records that don't have an event date provided. However, we have two errors here on rows 2 and 3 where there are some strangely formatted dates. So this one here on row 2 looks like there's a typo in formatting the date. And on row 3, the date is formatted incorrectly and does not follow ISO formatting. The rest of the errors are associated with blank dates. So again, this function can help you identify any dates that don't adhere to ISO formatting. Now we want to check eventIDs. This function will check that eventIDs are present and that any parent eventIDs provided have a corresponding event ID. So we can see we got 5 warnings here for rows 18 through 22. And we can't quite read the warning, so let's go ahead and store this in an object so we can view it. So the error message we're getting is that these rows have parent IDs that have no corresponding event ID. So let's take a look at our event table again, just to check this out. So it was rows 18 to 22. So let's scroll down to 18 to 22. So these all have the parent event CR 2013 STBC _3. And when we scroll up, we can see that where this event ID would be expected is missing. This may be because we simply forgot to fill in this row, or we forgot to create the row entirely for the parent event. So that can happen, and in these cases where parent event IDs are identified in this way, you will have to go back to the data to make sure an event ID and an event row is created for each of your parent event IDs. Now, related to this function is the check extension event IDs. This function will make sure that all of the event IDs in your extensions correspond to events in the event table. So let's check first for the occurrence table. We'll make sure that all occurrence records correspond to an event in the event table. And we can see that there are a few records that have no corresponding event ID in the event core. And these correspond to these rows here. And fortunately, it also tells us which event IDs are missing in the event core. So we can again double check in our event table. We can see that in this example, there are 2 blanks here, and these look like they would be associated with the missing event IDs. So we just have to fill that in there. Now we'll want to do the same thing with our EMOF table. So let's check that. And somewhat expected, since it was missing from the occurrence table, the EMOF table also has several records that are missing an event ID in the core. And these are the same event IDs that were missing in the occurrence table. And the last quality control check we're going to do is use the describe function from the package Hmisc. So this function is quite handy, and we'll take a look so you can see. What this function does is it provides a summary for each of the variables in your dataset. So you can see that for each variable, it's provided a quick summary, as well as the number of records, number of missing records, and the number of distinct records for each variable. This can be quite useful, especially when we're looking at our events, our event IDs. So we can see right away that there are 18 event IDs, but 4 are missing, which we've kind of had a hint at that from our checks previously. And there are 18 distinct event IDs. We always want these 2 values to match. The total number of event IDs in the event table should, of course, all be distinct. Looking at our event date column can be useful as well, because it can also indicate where some potential typos might be. So again, here we see typos and some non-standard formatting. So this is a great function to take a quick look at your data, as it quickly summarizes each of your columns and can give some insight on where some missing data might be. So before we finish here, I just want to emphasize how important it is to do these quality control checks before publishing, especially checking your taxa names and getting the worms identifiers into your data. And as a quick reminder, if you have trouble finding the identifiers, the scientific name ID for a species, please contact the worms team before you publish, and they can quickly help you resolve any missing species. And if you run into any other issues while conducting quality control checks, you can always reach out to your OBIS node or get additional help on the OBIS Slack.